Hello students, in today's session of electromagnetic waves, very basics will be cleared through illustrations. In this session, we are going to discuss how electromagnetic waves are generated, relation between EB and direction of propagation, Maxwell's equations, displacement current. All these topics are going to be discussed here through illustrations. Please go through the complete session. Right? Now let's start with the concept and questions. Concept regarding electromagnetic waves. How electromagnetic waves are generated. An accelerated charge produces a sinusoidal time varying magnetic field, which in turn produces sinusoidal time varying electric field. The two fields of produce are mutually perpendicular time varying electric and magnetic fields. They constitute electromagnetic waves which can propagate through empty space. When electromagnetic waves propagate in space, the electric field and magnetic field oscillate in mutually perpendicular directions and propagate in a direction perpendicular to both the fields. Means electromagnetic waves are generated through by accelerated charge. Accelerated charge and direction of electric field vector, magnetic field vector and direction of propagation. Electric field, magnetic field, x, y, z and direction of propagation. All are mutually perpendicular to each other. All are mutually perpendicular to each other. Graphically, it is shown here. One is this is electric field vector, this is sinusoidal. Then magnetic field, this is the magnetic field direction. And direction of propagation is along x-axis. It has been shown graphically also. Graphically, representation of electromagnetic wave. Right? Now in this case, if x is the electric field direction, y is the magnetic field direction, then direction of propagation will be along z-axis. Further concept will be clear through illustrations. Right? Now Maxwell equations. Now to discuss Maxwell equations. Maxwell equations are Gauss's law of electrostatics, Gauss's law in magnetostatics, Faraday's law of electromagnetic induction, and modified Ampere circuit law. Your Ampere Maxwell is circuit law. Right? In this case, E dot ds equal to 1 over epsilon naught charge enclosed by Gaussian surface. Right? In magnetic field, B dot ds equal to 0 as monopole does not exist. Next, Faraday's law of electromagnetic induction, that is E dot dl, equal to minus d phi by b over dt. That is all in Next, modified Ampere circuit law, that is B dot dl equal to mu naught IC plus IT. IC is the conduction current. IC is the conduction current and I is the displacement current. And ID is defined as epsilon naught d phi E over dt. D phi E over dt. This is the conduction current. It can also be represented as ID equal to epsilon naught dy dt phi E. That will be E dot A dt. E dot A. That is epsilon naught A dy dt E. Electric field equal to V by D. Then epsilon naught A over D dy dt V. That is equal to C dV by dt. ID is also given by this formula. Capsule rate of change of voltage, and it is also given by this formula. Right? Conduction current and displacement current forms continuity. This is generally discussed in capacitance, right? Where the space is empty. Now, let's start with the question. Question is, a plane electromagnetic wave of frequency 25 Hertz, megahertz, travels in free space along the x direction. At a particular point in space and time, E equal to 6.3 J volt per meter. This is the direction of propagation. What is direction of electric field? What is the B at that point? No. As we know, direction of propagation of electromagnetic wave is given by E cross B. E cross B. And also E naught over B naught equal to C, that is velocity of light. Direction of propagation is along x-axis. And direction of electric field is along y-axis. The direction of magnetic field will be along z direction according to this. Therefore, we have to find B equal to E naught by C K. E naught by C K Tesla. That is, E naught is 6.3 upon 3.1.3 into 10 to the power 8. Okay. सिंप्लीफाई कर लीजिए इसको, सिंप्लीफाई करके इसका आंसर आएगा 2.1 into 10 to the power minus 8 K Tesla. You know, I, J, K, you move like this. I cross J, K cross I, K cross I, J cross K, I. According to this, we can find the directions, right? Next question. Before I start out the next question, I would like to say that in earlier session, we have discussed displacement current and application definition of electromagnetic waves, which you can review on statistical term. In this case, illustration were taken from JE main. Also, these concept clearing videos, which are very helpful and useful for 11th standard, 12th standard, NEET, JEE, CUT, and other entrance examinations. Concerned में review on statistical YouTube channel. इसी के साथ साथ मैं रिक्वेस्ट करूंगा कि अगर अभी तक आपने स्टैटिस्टिकल यूट्यूब चैनल सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट and share with your colleagues and friends. Let's start with the next question. Question is, a plane electromagnetic wave propagating in the x direction has a wavelength of 5 mm. The electric field is in the y direction and its maximum amplitude is 30 volt per meter. Write suitable equations for electric field and magnetic field as a function of x and t. Concept applicable in solution. Now, as we know, as electric field vector, magnetic field vector, and direction of propagation. All are mutually perpendicular to each other. Now, in this case, direction of propagation means x direction, and direction of electric field is y-axis, positive. Therefore, B will be along z-axis, positive direction of z-axis. Direction of propagation of electromagnetic wave is given by E cross B, right? Now, therefore, E naught sine omega t minus kx volt per meter, that is equal to Ey. Bz will be equal to B naught sine omega t minus kx Tesla. Now, to find omega k and B naught and substituting in this one. Now, as we know, E naught over B naught equal to C. Then B naught comes out to be E naught by C. E naught is 30. 30 divided by 3 into 10 to the power 8. On simplification, this comes out to be 10 to the power minus 7 Tesla. This comes out to B naught. K, propagation constant, that is 2 pi by lambda. 2 pi upon lambda. Lambda is given to 5 mm. 2 pi upon 5 into 10 to the power minus 3 per meter. On simplification, this comes out to be per meter. 1257 per meter, right? And omega to 2 pi f, or you know C equal to f lambda. Omega की वैल्यू फाइंड आउट कर लीजिए. Omega comes out to be 3.77 into 10 to the power 11 radian per second. Substitute all the values, that will be the answer. If it is along negative axis, here will be plus sign, accordingly we will change the direction using the E cross B concept. Right? Next question. Question is, a light beam traveling the x direction is described by the electric field EY equal to this thing. An electron is constrained to move along y direction with a speed of 2.0 × 10⁻⁷ meter per second. Find the maximum electric force and magnetic force on the electron. Now, see. In this case, electric field is along y-axis. Direction of propagation is along x-axis. Therefore, direction of B will be along y-axis, as direction of propagation is given by E cross B, using that concept, and all three are mutually perpendicular to each other. Maximum magnetic force and maximum electric force. We have to find this thing, Fm and Fe, that is QE, that is QB cross B. Now in this case, take the same direction. Fe will be equal to Q 1.6 × 19 into E naught. E naught is 300. So this comes out to be 4.8 × 10⁻17 Newton. Maximum electric force on this. This is the answer. And maximum magnetic force will be equal to Fm is equal to Q VB sin theta. Angle between the axis theta is 90 degree. Substituting 1.6 × 10⁻19 into V. V is given 2.0 × 10⁻7. 2.0 × 10⁻7 into B. B will be equal to E naught by C. E naught by C into sin 90. Sin 90 is 1. Simplify it and find answer. Right? The answer comes out to be 3.2 into 10⁻18 Newton. That is the answer. Now, I would like to request, if you are new to my YouTube channel, SETI Shift Learn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.